This episode is brought to you by the Let's Code Physics Patreon supporters. In this episode, we're going to look at how you can create graphs using VPython. Here I've got a simple animation set up. We're going to create a sphere, name it ball. We're giving a step size of 1/2. We're going to wait for the ball to reach an x-coordinate of 1. We set up a nice slow rate so that we can see how things are moving along. And each frame we're going to increase the ball's position by the step size dx. Now I've thrown in a little bit of a twist here because each frame the dx is going to get cut in half. So we'll be doing Zeno's paradox where it moves half the distance, then half that distance, then half that distance, then half that distance. So it'll never actually reach x equals 1. And this is actually going to be useful for our graphing purposes. But just so you know what the animation looks like, so first it's going to step halfway across, then a quarter, then an eighth, then a 16th, etc. It's going to continue to move in tiny, tiny steps. It's still technically moving, it's just not moving far enough for you to see in each frame. And I want us to take a look at how we can graph this thing's motion. Because a lot of times what will happen in a physics class is you'll have your animation, the animation makes sense, it is physically doing what you want it to, but you need to be able to create a graph in order to actually study the motion, in order to be able to go back and see where was that maximum, where was that minimum, where was the slope the greatest, etc. So adding a graph to an existing code is a pretty straightforward process. You just need to follow 3 steps. The first step is to create the window where you're going to display the graph. So back over here we have an animation window. We then need to create a graphing window that's going to go beneath the animation window. We have to create this so that we can reference it later when we want to put objects inside here. The way you create the graphing window is using the graph command. Now I want you to notice I'm doing this outside of the loop. All right, so I'm doing this before I enter the loop because remember everything inside the loop gets repeated. I only need to create the graphing window once. If you put this graph command inside the while loop, which I have had students do, it'll create a graph every time we go around the loop. So you'll end up with many, many, many graphing windows. It's not what you want. At the very basic level, all you need to do is type in graph, open parentheses, close parentheses. It will create a graphing window. There are some options you can add though. For example, you can give your graph an X title for the label along the X-axis. This you just put in a string. You might say something like time. And then over here, you might put in a Y title. You might put in the position here. There are some other options you can add on here. We'll take a look at those in a second video for advanced graphing options. So that creates the graphing window. That literally just creates a box for you to place graphing items. Here what we need to do is create a graphing object. You have 2 options for that, G-curve and G-dots. Let's start with G-curve. So G-curve stands for graphical curve. At a very basic level, the only thing you need to provide here is a color. So we'll say color.red. And the other thing we need to do is give this thing a name. So we're going to call this position curve so that we can reference it later. Again, you notice I'm doing this outside the loop. If you do this inside the loop, it will create a new graphing curve in every frame of the animation. You don't want to do that. You want to do that before the loop begins. So I've created a graphing window. I have given a name to a graphical curve inside that window. But if I just run the code now, nothing else will happen, right? I'll get my animation. I don't see the graphing window down here because I haven't plotted anything yet. That's the third step, is plotting on the graphing object. Now this I do want to have inside the loop because every time this ball moves, I want to record its new position. So each time I go around the loop, I want to plot the ball's current position. So we're going to say position underscore curve dot plot, open parentheses, close parentheses. And inside here, I need to put the 2 variables that I want to graph. So on the horizontal axis, I'll want to have time. And on the vertical axis, I'll want to have ball.pause.x. Now, I haven't defined a time yet, so I need to do that. So we'll call this time equals 0. And each time we update the position, we'll also say time equals time plus 1. This is likely going to be time. If you're doing this graphing process in a physics class, this is probably going to be time and position, or time and velocity, or time and some sort of energy or something. This is almost always going to be time, but it doesn't necessarily need to be so. There's more advanced types of graphs you can create where this is not time, but we'll talk about that in another video. One other thing I want to point out is that each of the variables in here has to be a scalar. If you put in ball.pos.x, it will tell you that it cannot graph a vector. Right, so you cannot plot a vector, only a vector component. So that's reminding you that instead of ball.pos, what you actually want is ball.pos.x. So both of these have to be scalars. They cannot be vectors. So when we run this, press Control 2, we've got our animation moving along here, and then I've got my graphing window down here. I see my position along the vertical axis. I see my time along the horizontal axis. And the graph looks like what you would expect it to. It takes a big jump at first, then a smaller jump, then a smaller jump, then a smaller jump. And so it's going to keep leveling out here pretty close to 1. Now, of course, it never reaches 1. So this is going to keep marching on forever. So I might put in a time limit there as well. What you notice, though, is that I'm missing my initial point here. And that's because I have my plot after my update, right? So you have to think of this in order, right? The computer is reading these instructions in order. So I'm updating my position here. I'm using my plot command here. I could address that by cutting this and pasting it above here. So now I'm going to plot before updating. And so now we'll get that initial point of 0 on the graph. See that here? We start at 0 and we move along here. Now you can see it's got these jagged corners on the graph because it's basically saying that there's a point here and a point here and a point here, and a point here, and a point here. And it's connecting those points with lines, right? Because the ball is making discrete jumps. If I were to, make this more finely tuned, if I were to, decrease my time step or something, I could get this to be smoother. But at a basic level, this is always going to have jagged edges here because it's connecting those points. If you don't want it to connect the points, if you want it to just have dots here instead of a curve, then instead of a G-curve, you use the G dots object. So if just by changing that G curve to G dots, let's press Control 2. And here I get dots along my graph instead of connecting lines. So I don't have any more lines connecting in between these. I can just see the individual points. Now you see as I move my mouse over here, I've got a nice little trace here. So if I want to find a point on the graph, I can read that off here. That's a lot easier to do if the graph is not moving. So let's actually change this to while time less than equal to 10 ought to be good. There we go. So that the program will actually come to a stop and we can read the graph. And the nice thing about using VPython for your graphing is that it automatically updates each point, so you can see the graph animating at the same time as the animation window. Other graphing utilities will offer you more options, but they don't automatically do that, adding the points one at a time on the screen. So once I'm here, I can use my cursor to find the location of a point. So for example, for my third point here, I see that that's at an time value of 2 and a position value of 0.75. So anyway, whether you want connected lines going between these or whether you want them as individual dots depends on the type of graph that you want. It depends on how you want to visualize it. Depends on the instructions that you've been given. But VPython does offer you both options. Let's suppose I wanted to add a second graphing object. Like let's suppose I wanted to graph this thing's velocity, right? You know what velocity is, right? So velocity is the change in x over the change in time. So let's give this thing a dt of 1 here. So I can increase my time by dt. What if I wanted to graph my velocity in addition to my position? Well, what I could do would be to add another G-curve, right? I can take this, copy and paste it. And I can't give them the same name, right? I need to give it a different name. So I'm just going to say velocity curve. And let's make this on a curve. Let's turn this one back into a G-curve as well. And let's give this one a color blue. Now again, nothing new is going to happen if all I do is add a G-curve. I'm not plotting anything down here. So you need to get in the habit of every time you add a G-curve or G-dots up here, you need to also add a plot command down here. So we'll copy and paste this. We'll change this to VEL for velocity. And we'll change this value here to velocity. Now here's the thing, I have not created a new graph. Anytime you use a G-curve, it's going to reference back to the most recent graph it created. Let me show you what this means. I'm now going to get both of these on the same graph. So here I've got my position in red, I've got my velocity in blue. Now there's a couple of things that I'm doing wrong with this. One is I can't remember which one is which, right? I have to go back to my code and see, oh yeah, this one was red and this one was blue. So what I can do to tell them apart is use the label option. So whenever you have multiple curves on the same graph, you can use the label option to say that this is the position, and you can use label to say that this is the velocity. So that fixes that issue. Now when I run this, I've got a legend over here with position in red, velocity in blue, and that reminds me this is the position, this is the velocity. But I still have a problem with this because as a good physicist, I know that I can't graph position and velocity on the same chart because they have different units. So like for example, when they intersect here, there's nothing special happening there. They're not really intersecting because these are two different types of numbers. And so what I need is a new graphing object. I need a new graphing window. So I need to say graph, and let's just copy and paste this. Now I'll have a X title of time and a Y title of velocity. Now watch what happens. This G curve, position curve, was created immediately after this one, and this is created immediately after this one. So it's always going to default to the most recently created graph. So let's press Control 2 and see our two different graphing windows. Here I've got position, still got my label there. And down here I've got my velocity, still got my label there. You notice I've got velocity on the vertical axis here, position on the vertical axis here because I gave them different Y titles. VPython is kind to you in that it will assign these to the most recently created graph, but what if I want to add something to this graph later? What I can do is name this graph. So I can call this position graph equals this. And then when I want to add this G-curve to that graphing window, I just say graph equals position graph. And then I can do the same thing here. We'll call this velocity graph. And for my velocity curve, I can tell graph equals velocity underscore graph. So that should give me the same results here. So I get my position here. I get my velocity here. The reason that's handy is because if I create yet another curve somewhere, let's suppose I'm interested in not just motion in the X direction, but I'm interested in putting something in the Y direction. So I create a G curve, color equals color dot black, label equals Y position. Now what I can do, I can tell it graph equals position underscore graph. So I'm referring back to this first one I created. I'm skipping over vel graph. I'm referring back to this one here. Now when I run this, it's going to place my Y curve there. Now, of course, I have to plot something or else it won't show up there. So Y curve dot plot time comma ball dot pause dot Y. And we'll run this. And now what you'll see is that I've got my X position and my Y position in the same graph here. Now my Y position stays at 0, so that's just staying down there. Let's make that a little bit more interesting for you. Let's have the ball's Y position changed by half of the step size. So I'll move at an angle here. You can see it moving at an angle there. So here I've got my X position graph. I've got my Y position graph. You can see they're following the same general trend. The change here is always half of the change here, which is pretty interesting. And then of course I can do the same thing if I wanted to create a Y velocity. Let's actually give these a little bit better labels now so that I can distinguish these. So X position, X velocity. Oh, actually, no, I don't want to change that one. I want to change this one, X velocity. And then we'll do the same thing here. We'll make a VY curve, make this the Y velocity. And again, anytime you create a new G curve, you need to create a new plot here. So we'll call this one VY curve. We'll call this one VY. And VY is just going to be velocity divided by 2. I should really call this a VX now. There we go. So I'll change this velocity into a VX. There we go. So I have a VX and a VY. So we'll hit Control 2. Oops, I made a mistake. I put the wrong graph on there. I forgot to change this part. Oops. So I have to change this position to a vel. But it's easy to tell, right? Because I've got 2 positions and a velocity, right? I got 3 things on here when I was expecting 2. That's easy to fix, so I just changed that graph there. We'll press Control 2 to run. And so here I've got my position graphs, and here I've got my velocity graph. So you see it's really straightforward to manage these graphing windows. Again, all you have to do is follow 3 steps. First, you create the graphing window itself. Then you create a G-curve or G-dots as a trace or plot within that graph. And then inside the loop, you just need to add in a plot command referencing that same G-curve that you had earlier. With those 3 steps, you can graph anything you want or need in VPython. Thank you so much for watching. I will see you next time. Bye-bye.